A dozen years after the first approval of a biotech medicine, the first biotechnology-enhanced crop entered the marketplace. Today, scientists are using life science technologies to improve manufacturing processes, chemical synthesis, and agriculture feedstock production. Many people call this revolution the third wave of biotechnology, industrial and environmental biotechnology. One of the companies that has led the advance in industrial and environmental biotechnology is Genencor International. We have Jack Hutner, who's the Vice President for Corporate Communications and Public Affairs, with us today. Jack, Genencor's core business began with enzymes. What kind of uses do biotechnology-improved enzymes make in the world we live in today?
Well, enzymes actually are used quite a bit, and consumers find enzymes in many of the products they use in everyday life. For example, one of the most obvious and common uses in detergents. Enzymes have been very useful for the detergents to replace phosphates and some of the other chemicals in the detergents, and it has contributed to the reduction in the size of that box of laundry soap that people have on their shelves for Saturday, and reduces the amount of chemical load that goes into the wash water. And the end result, though, is cleaner clothes and a much less environmental impact. For example, lower wash water temperatures. So you can use colder water and get excellent wash water results or washing results as a result of the enzyme use. So that's one of the biggest uses.
Are these same enzymes used for other products for which enzymes would be normally used, like bread, beer, making that kind of?
Oh, enzymes, of course, are, have been used for thousands of years. They're used in the production of cheese and in brewing beer and in making wine. And what we do with biotechnology and some of the advances we've had over these last decades is to enhance the efficiency of the enzymes and make them more effective, and also to expand their use so that you can use them in other applications besides beer and wine and have the same kind of positive impact that we talk about when we use them in the detergent sector.
We're talking today about bioethanol, creating biotechnology, or using biotechnology to create bioplastics and those kinds of things. How is ethanol and biotechnology mixed? I mean, what's the use there?
Well, ethanol is basically it's a transportation fuel that is fermented, much like beer, by yeast cells, and is an additive in gasoline to replace MTBE. Automobiles can also run on alcohol, 100% alcohol. In this country, ethanol is blended with gasoline at about a 10% rate. What's exciting and useful for people to know about that is that as you replace MTBE, which has a lot of problems polluting groundwater, ethanol doesn't have that problem, and it's a fuel oxygenate so that gas burns cleaner and produces less smog. And the additional benefit, of course, with ethanol is it's made from corn and from glucose, which is a sugar that's derived from corn.
So is it possible that these enzymes would be using their natural process to create new fuels from cellulosic biomass and those kinds of things that are now we have to either burn or bury every year?
Well, what we like to talk about when we talk about biofuels is that instead of going to drill for oil, we're going to till for oil. If you can use the carbon from sugar in carbohydrates, instead of using the carbon from fossil dinosaurs, you can use a renewable source of material to make transportation fuel. In order to make that economically viable, however, you need to find a lower cost source of sugars besides grains like wheat or corn. And our solution to that is to use the waste streams from agricultural products. For example, corn stover, corn stalks, everybody's familiar with.
Sure.
If we can take the sugars out of that by using advanced enzyme systems, we will reduce the cost of the carbon and make economically viable ethanol that much more possible.
With this economic advantage, then, you would expect that the U.S. government would be jumping all over this and supporting it moving forward into the future. Is that happening?
Yes, very much so. As a matter of fact, the Department of Energy has a strong commitment to the development of biofuels. And in the last Farm Bill, the U.S. government went on record in support of the development of what we call biorefineries. And that is to use these renewable raw materials, these sugars, to make not only ethanol, but to make other chemicals like plastics and polymers and so forth, all with the objective of finding new markets for agricultural products, which will improve the economies on the farm, as well as reduce greenhouse gas emissions and have a more sustainable industrial system.
Right. We have an energy bill coming up, as you well know. Is there an opportunity for increasing this advance in that energy bill?
There are actually a couple of incentives in that bill that will help accelerate the adoption of these biorefineries. The other aspect of biotechnology in this that I might mention is that in order to convert these complex carbohydrates that come out of this agricultural waste stream, the Department of Energy has sponsored and supported over many years basic and applied research efforts to develop enzyme systems that break down these raw starch molecules into smaller carbohydrate molecules that fermentation organisms like this yeast can use. I know it sounds complicated, but basically it's a way to break down these big molecules into small sugars that yeast can make into ethanol.
This sounds very exciting, but the question most of our viewers will ask is, how soon is all this going to happen? And will I see a reaction, or at least in my pocketbook at the gas pump?
Well, we certainly hope it happens as quickly as possible, and we are starting to see the development of these biorefineries now. So more and more, the development of these biomass refineries are becoming a reality. To put a time frame on it, I would say the industry is expecting within the next 2 to 5 years the first of these biorefineries to begin production. They are expensive, and there are ways in which the government policymakers can help make those more, to accelerate the development of these, and we're working in the energy bill to make some of those things happen.
It sounds like this is all going to be cleaner, better, and greener. What can people who watch this program do to help support that concept and that initiative?
Well, I think when we look at using biological systems to make all of the stuff that advanced economies need, like fuels and chemicals, the more consumers demand of consumer products manufacturers that they use renewable raw materials and they use more sustainable industrial processes to make the things that they buy, whether it's plastics or fuel or other materials, that puts an incentive on manufacturers to find solutions that are more sustainable. And that's the way we in the biotechnology industry can help.
Great. Jack, thank you very much.
Thanks. It's a pleasure.
Modern industrial biotechnology is enabling a technological leap of dramatic proportions. Industrial biotech is realizing a level of productivity never witnessed before through the use of genomics, proteomics, and bioinformatics. Because of these recent advances in industrial biotechnology, we're witnessing the first phases of a truly historic economic transformation, away from an economy based on petroleum to a more diversified and robust economy where agricultural crops and crop residues will serve as the new, cleaner crude oil for the 21st century. The ability to use crops and cellulosic biomass, such as corn stover and wheat straw, to produce renewable feedstocks for energy and chemical production marks a giant step toward true sustainable manufacturing and new product development. The key driver in this new technology is the ability to change the cellulose in agricultural crop plant matter into sugars that can then be fermented to ethanol or refined into other value-added products. Industrial biotech companies like Genencor and Novozymes have developed microbes that can make enzymes, nature's own biocatalysts, that are able to break apart the cellulose in plants and convert the cellulose molecules to sugars. The animation you are watching shows how these biotech enzymes, called cellulases, operate at the nano level, operating as molecular machines to pick up strands of cellulose, cleave the individual sugars, glucose and cellobiose, and free them for production of ethanol fuel through fermentation. These enzyme catalysts have been perfected so that it is now economically feasible to make ethanol not only from grain, but also from corn stover, wheat straw, sugarcane waste, and many other agricultural crop residues. Enzymes are classified as either endo or exoglucanases. The endoglucanase, such as the E1 endoglucanase, break apart cellulose chains. During the process, the enzyme first binds to the cellulose chain, then forms a glycosyl enzyme intermediate, and lastly hydrolyzes the cellulose and releases it. The enzyme then diffuses to another cellulose site. Exoglucanase, such as CBH1, can then access the new cellulose chain ends. CBH1 begins at the point where the endoglucanase has broken the cellulose chain and moves along the entire chain until it reaches the end. Energy is released as each cellobiose unit consisting of 2 glucose molecules is released from the cellulose chain. Scientists believe that the energy is used by the enzyme to strip off the cellulose chain. The cellobiose and glucose released by these enzymes become available for conversion to ethanol through traditional methods of fermentation. Over the next few years, the magic of biotechnology will enable American farmers to harvest not just 1, but 2 crops from every field, a grain crop and a biomass crop. In doing so, the biotech revolution promises to create a positive economic upturn in rural America by growing markets for bioethanol and creating new jobs. Our next guest is Jim Stoppard, who's the Senior Director for Industrial Bioproducts at Cargill. Jim, what makes Cargill excited about biotechnology these days?
I think the thing that makes Cargill so excited is what makes me excited. I've been part of this industry, the chemical industry, for about 35 years, and we've heard a lot about ethanol and its promise, but in addition to ethanol, the chemical industry is about $1.5 trillion industry worldwide. And when you look at the $1.5 trillion, 2/3 or 3/4 of that can be replaced by renewable feedstocks. So it's a huge, huge growth opportunity, and I think we're just at the cusp of that taking off right now. And so you look at transformations in the chemical industry haven't occurred since the 40s and 50s when the industry really went to hydrocarbons, and now this is a transformation that I think could parallel that or equal that.
Is that sort of explaining the fit for Cargill and why this is a good business decision for your company today?
Yeah, I think it's a natural. When you look at the capabilities of the chemical companies, they have a toolbox that's been developed over the last 50 years. Mm-hmm. But those tools are all developed around hydrocarbons and the conversion of hydrocarbons. Cargill has a toolbox that's all related to renewable feedstocks. And we can reach into that toolbox and do things that it's going to take a long time for the chemical companies to do. And so it's a natural fit for our raw material base, it's a natural fit for our core competencies.
Let's talk about the opportunities out there in terms of products. Will Cargill, for example, build a biorefinery that would make ethanol or bioplastics, some of the exciting developments in those fields?
Well, I think this is why it's such a natural fit, is we've got biorefineries all over the world already in existence that currently take grain, either wheat or corn or all different kinds of grains, and convert them into food and feed and industrial products. And now when you hear about the biorefineries, typically in the industry today, it's about the conversion of cellulosic biomass.
Right.
Well, we can take those biorefineries that we've already have around the world and put in the front end of it a cellulosic biomass processing capability and plug them right into the biorefineries we already have in place.
Why is industrial biotechnology offering so much promise just for everyone else as well?
I think that's an excellent question, and well, you hear an awful lot about sustainability, for example, and sustainability principles can be applied to any industry. And when you look at what are the sustainability principles and how can they be applied here, first of all, there's the economic benefit, and I think that there's a huge opportunity for us to create new products, develop new economies, and then these, from a social standpoint, the social leg of the three-legged stool, it's new economies and new opportunities in geographies that today can't afford a hydrocarbon-based, but they can afford a renewable feedstock-based chemicals and plastics industry. And because these can be any raw material, any naturally based raw material anywhere in the world, There isn't really a geography in the world that can't participate in this, or a geography in the United States that can't participate in this. And also because you can build smaller plants than you have to in the chemical industry. To get the economies of scale, these plants have to be very large and very capital intensive. Right. In this industry, the plants can be much smaller and much less capital intensive.
So actually, the spread of the plants themselves can be localized or regionalized
Absolutely.
rather than a national or international
That's exactly right.
Marketplace.
And then the third leg of the sustainability stool is environmental. And I think just inherently, these products are much more environmentally friendly. The way the products are grown, less CO2 emissions into the air. I think there's huge environmental benefits for products that are made from renewable feedstocks.
You know, it sounds to me as if your approach and this advancement in industrial biotechnology makes it cleaner, better, and greener, not just for cargo, but for everybody involved in the products as well.
Well, I think it's a win for everybody. I think when you look at it, it's going to be a win, obviously, for the farmers. It's also a win globally, because you can go into underdeveloped nations around the world that don't have a hydrocarbon economy or basis, and they can grow their own crops for their future, and they can create energy from it. They can create products from it. So I think it's a win for everybody, and for the environment, it's the bioprocesses are naturally more environmentally friendly in terms of the types of processes that we employ and what we put back out into the environment. And then the products that we make are inherently environmentally more friendly as well.
I don't want to get out your crystal ball here, but what do you see in the future for this industry in the next, say, 5 or 10 years? Where's this going?
I think we've been spending a lot of time, not just we, Cargill, but the industry has been making huge investments in the technology over the last 5 to 10 years. I think in the next 5 years, you're going to start to see some of that technology being commercialized. Will it have a huge impact on the overall consumption of fuels and chemicals in the next 5 years? That's probably a little bit soon, because of the infrastructure that has to be built to make this happen. But you'll start to see commercialization of technology from now over the next 5 years, and then significant investments in infrastructure in the 5 to 10 year time frame.
What are the pulling factors to create the industry even faster? I mean, it's government influence and government support of these advancing technologies. But what about public response and public support for the products themselves?
Well, it's interesting. I think it's important. I think the public naturally wants to embrace these products. They're ready to buy naturally, or not natural, but renewable-based products. What we as an industry have to do is to bring the cost down so that they don't have to pay a cost premium, because what the public has shown over and over and over again is they want environmentally friendly products, but they're not willing to pay a premium to get there. Sure. And so I think that we've got to get over that hurdle and get the technology developed so that the public doesn't have to pay a premium to be able to buy these products.
So you think it's an industry sector that's bound for success?
Oh, I don't see how it can miss. We were on a very good path to success even before the recent run-up in energy prices. But the recent run-up in the volatility that's been around the energy costs over the last couple of years has really put the chemical industry into a lot of turmoil. And I think everybody's convinced now that the energy costs aren't going to back down. They may not, they're going to come down some, but they won't go back to traditional levels. If that's the case, we're going to be very, very competitive with hydrocarbon-based products in the future. And so I think that's been a huge change for us. So the combination of the technology being developed, the public waiting, they want to buy these products, and now the uncertainty of hydrocarbons in the future, I think all of these things are converging right now to really make this take off.
Thanks so much, Jim, for being with us today.
Oh, thanks for having me.
Industrial biotechnology will create a new era of bio-sustainability, but it will also deliver new ways to manufacture and even discover pharmaceuticals, innovative pathways for chiral compound production, special nanomaterials, vitamins, textiles, Plastics, cleaning products, fuel cells, pulp and paper, food ingredients, packaging, and even provide new ways to protect people from chemical or biological terrorism. It's called the third wave, industrial and environmental biotechnology.